Bismillah ar-Rahman ar-Rahim. Rabbi shrah li sadri wa yassir li amri wa halul uqdatam min lisani yafqahu qawli. Welcome back. I'm Dr. Hambacha, PhD Diagnostic Ultrasound Associate Professor. Today we'll discuss about refraction, right? So I'm searching for refraction. Yeah. Yeah. You know, refraction, the deviation of sound wave from its straight path is called refraction. So this is so half the glass should be filled with water. Then you have to put a pencil in it. The pencil will appear broken, right? So this is called refraction. So whenever the sound waves or light waves enter from one medium to another medium, so their two conditions must be fulfilled for the refraction to occur. There will be oblique incidence and there must be difference in speed of sound in the in the two mediums, right? So if both the condition fulfilled at the same time, then refraction will occur. So how will that refraction be? The sound wave will either be deviated towards the normal or away the normal. So the deviation of the sound wave towards or away the normal while passing from one medium to another medium is called refraction. And this reflection could be understood with the help of Snell's law, right? So do you know about the Snell's law? No. So Snell described the reflection of sound wave while sound wave passing from one medium to another medium. So Snell's described that the angle of incidence divided by the angle of transmission is equal to speed of sound in medium 1 divided by speed of sound in medium 2, right? So here theta I is the angle of incidence, theta t is the angle of transmission, c1 is speed of sound in medium 1, c2 is speed of sound in medium 2, and that is Snell's law. So according to Snell's law, just imagine if the speed of sound in medium 1 is 1000, if the speed of sound in medium 1 is 1000 and the speed of sound in medium 2 is 2000 and angle of incidence is 10, so what will be the angle of transmission? So you can easily calculate that without any calculator, without any other aid. You can say that if the speed of sound in medium 1 is 1000 and in medium 2 is 2000, it's mean it's doubled. Then the angle of incidence is 10, it will also be doubled, it will become 20. So that's too easy, right? Now, R, you can calculate it with the help of this formula. If you put these values in the formula, then you can rearrange the formula and you can calculate it. But now we came to the conclusion that if the speed of sound in medium 2 is greater than the speed of sound in medium 1, then the angle of transmission will be greater than the angle of incidence. So now it's too easy. Now it's rule of thumb. If the speed of sound in medium 2 is greater than medium 1, this is medium 1, this is medium 2, this is speed of sound in medium 1, this is speed of sound in medium 2. So if c1 is greater than if c1 is greater than c2, then what will happen? Then there will be a deviation of sound wave towards the normal. For example, this is incident sound wave, this is a reference line, and this is transmitted sound wave. So in this condition, if C1 is greater than C2, or you can say C2 is smaller than C1, mean speed of sound is smaller than this speed of sound, then what will happen? This deviation of sound wave will be towards the normal, right? Towards the normal. Then this angle will be smaller than this angle. This is 2 AZ. But if the speed of sound in medium 2, C2, is greater than C1, this is another condition, right? C2 is greater than C1, speed of sound of the C2 in medium 2 is greater than speed of sound in medium 1. Then what will happen? Sound wave will deviate away the normal. They will move in this direction. But the normal path the expected path of the sound wave was this one, this dotted line. Can you appreciate it? So this dotted line was the expected line, but due to refraction, the sound wave were either refracted towards this one, towards one, or towards two. So sound wave were refracted towards one if the speed of sound in medium two, or the speed of sound in medium two is smaller than the speed of sound in medium one. But if the speed of sound in medium 2 is greater than medium 1, then they are refracted towards 2, right? So that was true AZ. And what was the need of this refraction? I mean, what is the clinical significance of refraction ultrasound? Why we are discussing about it? Why we are wasting our time on the Snell's law? So that is at most important, because refraction is the mother of artifacts. Majority of the artifacts are created due to refraction. That's why we are going to discuss, and we are going to know about the refraction of sound wave. So it was all about refraction. Here in this example, you can see angle of sorry, both of them are written over here as t, but here you can see this is tt, then theta t, and this is theta I. This one is theta I. Theta t mean angle of transmission is greater than angle of reflection. That means speed of sound in medium 2 is greater than speed of sound in medium 1. And now this is another example. Here you can see the transmitted angle theta t is smaller than the theta I, and here you can see the speed of sound in medium 2, C2 is smaller than C1. C2 is smaller than C1. So these are different condition of the Snell's law, and according to this Snell's law, you can have different artifacts. So here you can see this is a numerical example, and in this numerical example, you can see that the angle of incidence is 20 degree. The speed of sound in medium 1 is 1000 meter per second, and if the speed of sound in medium 2 is 2000, what will be the angle of transmission? So that is AZ. The angle of transmission will be 40 degree, right? If you want to calculate it with the help of this equation, so you can rearrange the equation and put the values in it, then you will get the correct answer. If you have any question related to the refraction law, you can ask. It was the end of today's sessions. Do you have any question?
Thank you, sir.
No question at all?
No, sir.